Welcome to today's session. Today we are going to learn about the advanced models which are used in the field of regression. So far, we were talking about regression analysis using linear models. For example, linear regression, ridge regression, lasso regression. Those are linear models of regression. But as we know that in real world, the data that we have may be non-linear in nature. So what to do in those cases? Do we have some non-linear models of regression available with us? Yes, we have non-linear models of regression. What that means is either the mathematical equation which is involved is non-linear in nature. For example, instead of y equals to m of x plus c, my equation can be y equals to m1 x1 whole square plus c, where it is a quadratic equation of the degree 2 and it will be known as polynomial regression, guys. Okay, so we have non-linear models of regression means where if there is a mathematical equation, it will be non-linear in nature like this. Okay, y equals to m of x square plus c, which is polynomial regression. Then we have some other advanced models like support vector machine where there are different kernels. There is a linear kernel also, but we are talking about non-linear kernel, which is polynomial kernel, radial basis kernel, sigmoid kernel. So then SVM behaves as non-linear model. We have KNN model, we have decision trees. Okay, these are different models which are non-linear in nature. Using decision tree, we can further have advanced models known as bagging model, which is random forest, or boosting model like ADA boost, gradient boost, and so on. Okay, what we will be focusing today on is the decision tree models, one of the most important models in the field of machine learning. So here, if you see on my screen, I am going to tell you about how decision tree model works. Even though it is mentioned classification here, we can use decision tree models for regression also, guys. So our agenda today is to talk about decision tree in terms of regression analysis. So let me tell you some internal details about this model. So decision tree models, they are the non-linear machine learning models as we discussed. So how are they non-linear in nature? There is no equation here. It don't have any quadratic equation, okay, or any cubic equation, no. But why it is non-linear is because of this nature of the tree that it builds. It is non-linear in nature. We will talk about that, how it fits to the data. Ultimately, when we talk about any equation, we say, okay, this equation is ultimately going to fit on the data so that we get the values of coefficients, correct? Here in decision tree, we are saying our tree will fit on the data. That means ultimately the output of the training phase will be a decision tree, and that decision tree will help us in getting the output, whether a regression output or a classification output, that we will see. So ultimately, the training phase of decision tree yields a decision tree in this format, using which we can get the output, a regression output or a classification output. Let's see that. So before we proceed ahead, in general, we all should know what is a decision tree or how to understand a decision tree. So guys, every decision tree always starts from a root node, right? This is a root node. And then these are the branches. And further on, there are branches till you reach the leaf nodes, right? These are the leaf nodes. And these are the intermediate nodes. Okay. So remember, when I am saying decision tree, means after training the model, you will get a decision tree. It will be of this form. So first you should understand how to interpret a tree. A decision tree is always like a root node, and then there are intermediate nodes, and finally there are leaf nodes. Leaf nodes are the ones which have no further child. Okay. But now, how do we use decision tree in the field of machine learning? So let's understand that based on someone's age and salary, you have to predict the amount of loan that we can give to that person. Okay. So here at the root node, the very first column that we will use is age. And let's say we have a threshold of age less than 40. So at the root node, the choice is age less than 40? Yes or no. So based on this, we will decide that for a given person who is coming to ask for a loan, we first check his age. If he is of 30 years age, we will go to this side because age is less than 40. Then here we will check that person's salary on these two nodes. So here, let's say we are checking for salary. Is salary, let's say monthly salary is less than 1 lakh? Yes or no? Okay. Now, if the salary is less than 1 lakh, let's say for this person's salary is 70K per month. So he will ultimately land into this path of the tree. And whatever is the value here, we can predict that as an output for this person. So let's say first we have to predict whether this person is eligible for loan or not. So that is a classification. So it can be yes or no here. In case of classification, we are predicting whether to give loan or not. But in case of regression, let's say here we have the value that this person is eligible for loan of, let's say 7 lakhs, but this person is eligible for, let's say 70 lakhs. Okay. So ultimately in the leaf node, we will have the output, desired output hidden. So we will be tracing the tree based on the features of a given person. Getting my point? So the question is how this decision tree is built. Okay, guys. So from the training data, when we train the decision tree model, ultimately it learns all these information and plots this kind of a tree, so that on the test data, when you want any prediction, you run test data over this tree, trained or learned tree, to get your prediction. So that's how, first of all, the decision tree model works at a very high level. So we'll start from the root node, check for this person age is less than 40. Okay. Salary is less than 1 lakh. Okay. So finally we land here, and whatever is the value at this position, let's say if it's a number, we will say he's eligible for 7 lakhs loan. Okay. So we all understood, right, that ultimately the output of a training phase is going to be a decision tree. But how that decision tree is built in itself is based on some mathematical calculations.